good afternoon everyone. This is Miss Mate and we will be talking today about a technique of finding the limit of a function, and the technique we are talking about is by factoring. Okay, so by factoring. Now, I'm going to give you the function that you have right here, f of x equals 3x squared plus 3x minus 6 divided by negative 2x squared plus 7x minus 5. And what I want to find limit as x approaches 1 of f of x. What is the first thing that most of the students will start doing first? They would say, oh, finding limits is easy. All I have to do is limit as x approaches 1 of f of x. I need to replace the value of x equals 1 into the equation of the function. So what I get is 3 times 1 squared plus 3 times 1 minus 6 divided by negative 2 1 squared plus 7 times 1 minus 5. So I get 3 plus 3 minus 6, it's a 0, over negative 2 plus 7, 5 minus 5, 0. So from this point, usually students draw the following types of conclusions. Some people might tell me there is no limit. Some people might tell me, oh, the limit is 0 because I'm doing 0 divided by something. Other people might say, oh, the limit is infinity because I divide by 0, and I remember something that when I divide by infinity, the limit is 0. Okay, now, these are all just scratching the surface. What we need to do, we will be looking together at the graph of this function that I have for you right here. This is a graph of f of x. If you do not believe me that this is indeed the graph of f of x, please grab a graphing calculator or any graphing software, use any graphing software and graph this for yourselves. What do I see? I need a limit as x is approaching 2. X is approaching 1. Sorry, I can approach 1 both from the left side and I can approach 1 from the right side, like that. My intuition tells me, looking at this graph, that when that happens, the function is approaching both from the left and from the right. The function is approaching the value 3. This is what I see. From left, I am approaching 3. From right, it seems like the function is approaching 3 as well. Please notice that I didn't say that the function, the value of the function at 1 is 3. I have never said that. I am saying the limit, intuitively, I feel like the function f of x is approaching 3 as x is approaching 1, both from left and from right. The question is how that was intuition is not enough. I need to find that limit algebraically. So what I suggest we do, we take both the top and the bottom of this fraction and we try to factor. Let's see if it's possible. I notice a common factor of 3x squared plus x minus 2. I continue 3 times x minus 1, x plus 2. Let's make sure I double check. X squared minus x plus 2x. It's a plus x minus 2. Yes, this is correct. And now the other one, so I have this one. Let's move it, sorry, let's move it out of the way just to make sure that doesn't interfere with what I do next. So this one can go right here. The second one is the bottom of this fraction, negative 2x squared plus 7x minus 5. Negative 2 times negative 5 gives me a 10. I need two numbers. When I add them, I get 7. When I multiply them, I get 10. 2 and 5. So that helps me to break down the middle term into positive 2x and positive 5x minus 5. So first two terms, I group them. My common factor is negative 2x, x minus 1 plus 5 x minus 1. Look how lucky we are. X minus 1, x minus 1 common factor. So let's factor it. It's gonna be x minus 1 and then in the bracket negative 2x plus 5. Good. Now that means we are not going to need this. This is a detail. This is not part of my big picture. It was just a little thing that I need to do at the side. I am going to get rid of it. And what's important for me is that I can rewrite my f of x or limit as x approaches 1 of f of x. This becomes limit as x approaches 1 of the numerator became 3 times x minus 1 times x plus 2, and the denominator became x minus 1 negative 2x plus 5. Let's take a moment and think about this function. Let's take a moment and think about the function f of x that right now looks like that. What do I notice about this function? I look at the denominator, and what do I see? I see I have two problems here. For x, the function is not defined. The function is not defined for x equals 1, when x minus 1 equals 0, x equals 1, and for negative 2x plus 5 equals 0, x is 5 over 2. For these two, so x cannot be 1 and x cannot be 5 over 2. Let's take a look at the graph. What can I see here? Obviously, I have indeed a vertical asymptote at 5 over 2, which is 2.5. The vertical asymptote is right here. We all see it. Is this vertical line? Mine is not that vertical, oh God. Going through 2.5, there you go. That's a vertical asymptote. So that was easy. Now, for x equals 1, the other value, I don't have a vertical asymptote, but what I have a hole in the graph. Okay, so that means, let's see what that means. How do I continue evaluating my limit? What I need to do, I need to notice that I have a common denominator of, I have a common factor of x minus 1. I can divide both the numerator and the denominator by x minus 1, and the function becomes limit as x approaches 1 of 3 times x plus 2 divided by negative 2x plus 5. And that becomes, when I substitute x equals 1 into that expression, that becomes 3 times 1 plus 2 over negative 2 times 1 plus 5. Please notice, and that's extremely important, please notice that I am not using the limit symbol anymore because I'm evaluating the limit. I don't need the limit symbol. So this limit becomes 3 times 3 is a 9 over 3. The limit is 3. What a big surprise. I figured that out from the beginning based on my graph. So there you go. This is the algebraic way to figure that out. I use factoring. Thank you and have a wonderful day.